Alright, good morning. We are going to be solving polynomials, and we're going to look at two examples. So the first example we are looking at is 2x squared minus 8x minus 42 equal to 0. So if you recognize that this is a quadratic equation, right, we have a highest degree of 2. So looking at this problem, what we want to do first is to divide by a GCF of 2. So if I divide all the terms here by 2, including the 0 on the right, we end up with x squared minus 4x minus 21 equal to 0. Now, I divided by 2 because then it makes it easier now I have smaller numbers to work with. So looking at x squared minus 4x minus 21, this can be factored into x minus 7, x plus 3. So now I have two factors, x minus 7 times x plus 3, and that equal to 0. Now using the product rule, for those who don't remember, if two numbers multiplies to 0, then it means that either one of them or both of them are equal to 0. So with that, it's either a is equal to 0 or b equal to 0 or both of them equal to 0. So using the product rule, we can just say that if x minus 7 times x plus 3 equal to 0, then it means either of them could be equal to 0 or both of them could be equal to 0. So with that, we can say that x minus 7 equal to 0 or x plus 3 equal to 0. Therefore, when we solve for x, we can have x equals to 7 and x equals to negative 3. So these are the zeros of this equation, right, or the solutions of the equation 2x squared minus 8x minus 4. So this means that if I plug in 7 for x, this whole expression will be equal to 0. Likewise, if I plug in negative 3 for x, then this whole left-hand side will be equal to 0. Now let's look at example 2. Example 2 says 2x cubed minus 5x equals to 3x. Now, this is a cubic polynomial. It has a highest degree of 3. So what we want to do is to make the right-hand side 0. In other words, I would like to move the 3x to the left-hand side. So I end up getting 2x cubed minus 5x squared minus 3x equal to 0. It is positive on the right-hand side, so when I move it over, it becomes negative, right? So now, with this polynomial, I can see that there is a greatest common factor of x. So I'm going to take out a GCF of x. So then we end up with 2x squared, because if I divide x cubed by x, I get x squared, minus 5x, again we're dividing x squared by x to get x, minus 3 equal to 0. When I divide x by x, it becomes 1. So after taking out the GCF of x, this is what I'm left with. Now, we can see that the 2x squared minus 5x minus 3 can also be factored. We can break it down further into, we still bring this x into 2x, right? This 2x squared becomes 2x and x. Then I need to find two numbers that will multiply to negative 6 and add to negative 5. So when I'm looking at it, I can do minus 3 here and plus 1 on the side. Okay. So if you have forgotten your factoring, I would recommend that you go do some review. All right. So now I have how many factors here? 1, 2, 3 factors. 3 factors. So again, using the same product rule, if two numbers or 3 numbers multiply to 0, then it means that either one of them equal to 0 or all of them equal to 0. So with that rule, I can say x equal to 0, the first factor, or the second factor, which is 2x plus 1 equal to 0, or x minus 3 equal to 0. So now, on this side, there's nothing we can do. We're done here. Here, when we solve for x, we end up with x equals negative 1/2. If I subtract 1 on both sides and divide by 2, I end up with that. And lastly, when we add x on, if I add 3 on both sides, we end up with x equals 3. So these are the zeros or the solutions to that equation. And remember, this is a cubic polynomial. It's a degree of 3, so we're expecting to get 3 solutions, right? 3 solutions, because the highest degree is a 3, it's cubic, right? Likewise, when you look at example 2, the highest degree is 2, so we're expecting 2 solutions, and that's what we have here, right? So these are 2 examples of how to solve polynomials using the factoring method. Thank you for watching. See you.